Since humanity first set foot on the moon in 1969, we have bridged a half-century technological divide to finally turn our gaze toward Mars and the even deeper reaches of space. This represents not only a leap in rocket thrust, but also a collective breakthrough in hundreds of technologies, from life support systems and deep space communications to radiation protection. When humanity's innate thirst for knowledge meets ever-evolving technology, we finally tear open a corner of the universe's mysterious veil. Once we could only gaze at the stars and dream, but now we can forge precision probes to traverse billions of kilometers on our behalf, touching those mysterious planets once confined to textbooks. Among the many feats of deep space exploration, the journey to Saturn stands as an epic. This gas giant, adorned with an elegant halo, once baffled Galileo when he observed it through primitive telescopes in 1610. Today, the Cassini-Huygens probe successfully completed 2 decades of in-depth exploration. Equipped with particle analyzers, infrared spectrometers, and high-definition cameras capable of kilometer-level resolution per pixel, it has unveiled layer upon layer of Saturn's secrets. If you too yearn to continue this cosmic journey, fuel our mission with your likes. Subscribe to the Jinming Daily channel and let us anticipate the next interstellar adventure together. Now fasten your seatbelts. We're about to embark on a mysterious voyage to Saturn. As the 6th planet in the solar system, Saturn orbits the Sun at a solitary distance of 1.4 billion kilometers, equivalent to 9.5 times the Earth-Sun distance. It takes nearly 30 Earth years to complete one orbit. Even at its closest approach to Earth, a vast chasm of 1.2 billion kilometers still separates them. Its equatorial diameter spans 120,500 kilometers, enough to fit 750 Earths within it. Its mass is 95 times that of Earth, yet primarily composed of gas. Its density is lower than water, earning it the title of the floating planet. Millennia before telescopes were invented, ancient Sumerians had already cataloged Saturn in their star charts. Its most striking feature, the ring system, is actually a rotating disk composed of billions of small celestial fragments and ice crystals, with its widest span reaching 1.5 times the Earth-Moon distance. Named after the Roman god of agriculture, Saturn, its astronomical symbol symbolically represents a sickle for harvesting. Delving deeper into this gas giant, its outermost layer is an atmosphere over 1,000 kilometers thick, composed of 97% hydrogen and 3% helium, interspersed with methane and ammonia forming golden cloud bands. Beneath its frigid surface at 140 degrees, as depth increases, gaseous hydrogen gradually transitions into liquid metallic hydrogen, forming a unique conductive layer approximately 14,000 kilometers thick. Deeper still lies a rocky core encased in high-pressure ice. Despite surface temperatures reaching 13,000 degrees Celsius, pressures equivalent to millions of atmospheres lock water molecules into a solid crystalline structure. Regarding the idea of human colonization on Saturn, scientists are unequivocal. This planet, lacking a solid surface, cannot sustain human life. Yet its satellite system holds surprises. Among the 82 confirmed moons, Titan stands out. As the solar system's only moon with a dense atmosphere, its nitrogen content surpasses Earth's. Rivers, lakes, and seas of liquid methane flow across its surface, making it a frozen model of primordial Earth. Let's rewind to October 15, 1997 at Cape Canaveral, Florida. A Titan IVB rocket blasted through the clouds, propelling humanity's most sophisticated interstellar envoy, the Cassini-Huygens probe, into deep space. This 5.6-ton combined probe, carrying 18 precision instruments, embarked on a 7-year journey, 3.5 orbits around the inner solar system, using gravitational slingshots. In the summer of 2004, when Cassini first entered Saturn's orbit, the close-up images of the rings it transmitted sent the entire control center into a frenzy. During the perilous moment of traversing the F-ring, the probe not only captured the newly forming moons S2004-S1 and S2004-S2 coalescing within the ring gap, but also unexpectedly discovered periodic spiral density waves within the ring structure. That same Christmas, the Huygens probe separated from its mother ship, descending like a shining star toward the orange-hued Titan. After 3 weeks of solitary drift, this 2.7-meter diameter disc-shaped probe plunged into Titan's atmosphere at 6 kilometers per second. Following 2.5 hours of frantic deceleration, it achieved a soft landing on the frigid 180-degree ice plains. Remarkably, images captured during the descent revealed familiar landscapes, winding channels converging into deltas, eroded gravel scattered along coastlines. Though flowing liquid methane rather than water, the gullies carved by erosion bore striking resemblance to Earth's rivers. Near the landing site, the probe even detected surface moisture anomalies, suggesting recent methane rainfall. These discoveries have thrilled astrobiologists. While Titan's environment is inhospitable to humans, its complex organic chemistry may be fostering entirely new life forms fueled by methane. This 2-decade deep space expedition transmitted 635 gigabytes of raw data, spawned over 4,000 top-tier scientific papers, and fundamentally reshaped humanity's understanding of the outer solar system. When the James Webb Space Telescope re-examined Saturn in 2023, newly discovered intermittent plumes reminded us every answer begets new questions. As Cassini Project scientist Linda Spilker stated, "We are not closing a chapter, but building a bridge to the next generation of even more spectacular exploration." Cassini's journey was far from smooth sailing. Over its 20-year mission, 1997-2017, it not only reshaped our understanding of Saturn, but repeatedly demonstrated miracles of human engineering in the face of extreme adversity. It ventured 22 times through Saturn's outermost F-ring, a region teeming with dynamic phenomena and potentially lethal ice particles. Each crossing was a gamble with the unknown. In doing so, it revealed Saturn's rings aren't static relics, but a vibrant, evolving micro-sun system that may even be birthing new, tiny moons. Encounter with Enceladus, the source of life beneath the frozen world. If Titan offered a glimpse into Earth's past, Saturn's other moon, Enceladus, delivered the mission's most thrilling discovery. This seemingly ice-covered dwarf planet, just 500 kilometers in diameter, initially held little promise for scientists. However, during a close flyby in 2005, Cassini captured astonishing imagery. Massive ice geysers existed near Enceladus's south pole, with plumes rich in water vapor continuously erupting from cracks in its icy crust hundreds of kilometers into space. Subsequent analysis delivered earth-shattering revelations. These plumes contained not only water ice particles but also simple organic molecules like methane, propane, and ethane, along with, crucially, salts and tiny silica particles. All this evidence strongly points to one conclusion. Beneath Enceladus's icy crust lies a global, warm, liquid ocean with hydrothermal activity on its seafloor similar to Earth's deep-sea vents. Here, the three fundamental elements for life are present: liquid water, organic molecules, and chemical energy. Enceladus has leaped to become one of the most promising candidates for extraterrestrial life in the solar system, aside from Earth. A grand finale, Cassini's grand finale. To prevent potential contamination of potentially habitable environments like Enceladus or Titan by Earth-based probes, NASA designed an epic farewell for Cassini, the grand finale. During its final mission phase, Cassini undertook a series of unprecedented daring maneuvers. It repeatedly traversed the narrow gap, approximately 2,000 kilometers wide, between Saturn's disk and its innermost ring, a region never before explored by any spacecraft. During this suicide exploration, it measured Saturn's gravitational and magnetic fields with unprecedented precision, analyzed the composition of the planetary rings, and transmitted the clearest images of Saturn's atmosphere ever captured. Finally, on September 15, 2017, Cassini plunged headlong into Saturn's atmosphere at over 120,000 kilometers per hour. In its final minutes, it continued adjusting antenna angles, striving to transmit precious last-minute data on Saturn's atmospheric composition and temperatures back to Earth 1.4 billion kilometers away, until its signal vanished into cosmic silence. Its fiery descent, like a brilliant meteor, marked both the end of its mission and its final, most profound salute to the planet it had explored. The future is here, a new mission to Saturn. The Cassini-Huygens saga has concluded, but the torch it ignited continues to burn. Building upon its astonishing discoveries, NASA has officially approved the Dragonfly mission. This is no conventional lander or rover, but a nuclear-powered drone. Scheduled for launch in the 2030s, it will target Titan directly. Within Titan's dense atmosphere and low gravity, Dragonfly will flit between locations like a dragonfly, exploring dunes, impact craters, and potentially landing on ancient lake beds. It will systematically search for prebiotic chemicals and even signs of life itself, possibly unlike anything found on Earth. From Galileo's perplexity to Cassini-Huygens' two-decade vigil, and now Dragonfly's imminent intelligent flight, humanity's exploration of Saturn embodies the most vivid expression of our civilization's curiosity and pioneering spirit. This is not merely a scientific expedition, but a philosophical pilgrimage, continually posing profound questions. Where do we come from? Are we alone in the universe? And the answers may well lie hidden within Saturn's realm of ice and fire. Cassini's legacy extends far beyond its direct discoveries. It fundamentally reshaped how we search for life within our solar system. It taught us that habitable zones are not confined solely to the golden zone, where planets orbit stars at just the right distance. Within the icy moons of giant planets, heat generated by tidal friction can similarly create inner ocean worlds capable of nurturing life. Enceladus, this unassuming little world, has now become a star in the field of astrobiology. Saturn's curiosities, beyond Titan and Enceladus. Yet the wonders of Saturn's family extend far beyond these two star members. Cassini also revealed a gallery of moons brimming with contrasts and marvels. Mimas, famous for its striking resemblance to the Death Star from Star Wars. Its massive Herschel crater spans nearly 1/3 of the moon's diameter, leaving scientists puzzled about how it survived the impact. Saturn VIII, Iapetus, a mysterious yin-yang sphere. One side is as dark as coal, while the other gleams like snow. This extreme dichotomy remains an enduring puzzle for scientists. Its equatorial region also features a peculiar mountain range soaring 20 kilometers high, resembling an equatorial spine running through the moon. Saturn VII, Hyperion. A porous, irregularly shaped sponge-like body, Hyperion ranks among the solar system's most peculiar known objects. Its surface is pockmarked with deep craters, and its extremely low density makes it resemble a giant pile of ice shards tumbling through space in a seemingly chaotic, irregular rotation. The hidden connection between Titan, Dione, and Enceladus, Cassini discovered an incredible magnetic link composed of high-energy particles connecting Titan and Enceladus. This reveals Saturn's complex magnetic environment acts like an invisible bridge, facilitating some form of energy and material transfer between its moons. Unresolved mysteries and future calls. Though Cassini's mission has concluded, the treasure trove of data it left behind continues to be analyzed by scientists worldwide, yielding new discoveries. Simultaneously, it has left us with many unresolved questions. The age of Saturn's rings. Are the magnificent rings we observe co-formed with Saturn, over 4 billion years old, or did they form relatively recently, possibly just hundreds of millions of years ago, from a shattered comet or moon? Saturn's internal secrets. What is Saturn's true rotation period? This seemingly simple question becomes extraordinarily complex because the gas giant lacks a solid surface, and magnetic field measurements yield conflicting results. Depth and composition of Enceladus Ocean. What lies at the bottom of its global ocean? How intense is its hydrothermal activity? Could it harbor chemical reactions beyond our imagination, or even life? Titan's methane cycle. Are methane rains on Titan seasonal? Does its subsurface liquid water layer exchange with surface organic matter? This moon's chemical complexity far exceeds our models. Humanity's next embrace, Dragonfly, and the distant future. To answer these questions, especially regarding Titan's exploration, the Dragonfly mission represents a revolutionary paradigm shift. It will no longer settle for probing a single location, but will fly hundreds of kilometers over several years, traversing Titan's vastly different terrains, from organic dunes to dried lake beds to young impact craters. It will analyze surface composition, monitor atmospheric changes, and even use seismometers to listen to Titan's internal activity. Its goal is to directly assess Titan's habitability and search for potential chemical signatures that could indicate the presence of life. Beyond Dragonfly, scientists are already envisioning more ambitious missions, cryogenic submersibles capable of drilling through Enceladus's icy crust, or swarms of intelligent probes navigating Saturn's rings. These concepts, once confined to science fiction, are now evolving into blueprints thanks to the success of Cassini-Huygens. From Galileo's hazy halos to Cassini's breathtaking images of Saturn rising above Titan's horizon, humanity's exploration of this ringed planet has been a 4-century symphony of reason and romance. Each answer has sparked deeper, more profound questions. This unceasing curiosity is our species' most precious trait. This journey to Saturn never truly ends. It merely transforms, shifting from the sensors of probes to the tearful excitement of scientists in ground control centers, to the dreams of countless children gazing at the night sky worldwide, and to each of us ordinary people following the latest discoveries through our screens. If you wish to stay updated on the construction progress of the Dragonfly mission, learn about the latest research in the Saturn system, and witness every new footprint humanity takes toward deep space, be sure to like, bookmark, and subscribe to our channel. Click that little bell icon, and you won't miss a single thrilling interstellar launch. In the comments section, feel free to share the cosmic mysteries you're most curious about. They might just become the destination of our next mysterious journey.